Hello, everybody. Thanks for coming here and still being with me after 2 o'clock on the second day. It's very nice of you. So, as Barry mentioned, my name is Sonia, and I'm going to present a little bit about the story of Chase, actually. So, don't let the title fool you. I said that it's feature-driven design being the Microfrontends' best friend, but what it's actually going to be, it's going to be a journey I will take you on. And it's a completely new journey that is going to be full of, well, maybe courage, maybe tears, a little bit of success, but also then just slowly settling down. So here we are. This is our Chase app. I know that you guys are probably not familiar with it. I'll get to it a little bit later, but I have to start saying that I feel very honored being able to be in here, amongst so many veterans. This is my first time in here, and that's why I decided I'm going to tell you a little bit about myself. So, to all the folks in the back, this is me, and I am going to pretend to be a very enthusiastic person every single time there are socks involved. So this is me getting the flutter socks. I would like to give a big shout out to Sentry and to Callstack for organizing very good merch. Hint, hint. Callstack, I still don't have a pair of yours, but I'll get there. So I am actually a robotics engineer. I used to write in C and C++ for 5 years of my university, and I moved to JavaScript because I hated C and C++, so I guess the joke's on me, right? And I've been working for Chase for over 4 years now. So actually, a little note about me. I am Polish, even though Barry can roll his R's much better than I do. And pozdrowienia dla Katowic z Wrocławia. Thank you, guys. So my job in Chase is being the design system lead, and this is something that definitely helped me in discovering my passion for the front-end architecture, because I believe that having good principles in everything is going to lead to success. And also, as you might have guessed, and I probably think that many of you started the journey in a similar way, I started from being a React developer, and this is something that took me to mobile development in the end. So, as I introduce myself, I am also going to very briefly introduce my company. So this is Chase UK, and this is our awesome app. I know that you might not know what it does, but Chase is actually a first non-challenger mobile-only bank in the UK. What is a non-challenger bank? It's a bank that is just like Monzo or Revolut, but it's actually backed up by a lot of money. And we managed to get over 1.6 million users in less than a year and a half from the launch. We've been active for nearly 2 years right now. We're one of the fastest growing banks in Europe. So I did mention Monzo, Revolut, forgot about Starling, but here we are. And in the UK, we already managed to win multiple awards. So a fun fact about Chase is we started as a greenfield project. And I know that it doesn't seem as a big achievement when we talk about startups and things like this, but try getting a greenfield project set up in a company that has over 200 years of history. It's not that easy, let me tell you. So I think the most important thing for this particular conference is we are built with React Native. And you can see that this is just an app like any other, right? So, speaking of just an app like any other, what are the React Native humble beginnings? We're getting the magic spell, put it in terminal. It's npx React Native, init my new project, and here we go. This is like the boilerplate for every single React Native application. I mean, I haven't been in there 4 years ago. 4 years ago, yes, not more than that. So I don't know if this is how it all started, but I think that this is how this would start today, right? So we've got our iOS, we've got our Android directories, and then we just have a bunch of files that don't really belong anywhere. So speaking of that, we're taking ourselves on a journey back to the times when monolith architecture used to be popular. So let's say that we're starting the new React Native project. What we're trying to do is we're trying to probably get it running as soon as possible, but also not to really start it with a big mess. So we're starting dividing the things for flows. We have some screens, some hooks, and some helpers. Well, this is just as it was some time ago, right? So looking at pros, I think that it was Michal who mentioned that in 2015, it was the microservices that started being super popular, and it was the way to go. But you have to know that there is no single way that actually works for every project, right? I don't really support monolith architecture anymore, but I think that for small projects, everything can be done just in this way. So you still have your Android, your iOS folders, and then you just have a bunch of directories where you can stack all your utilities, make it work. And if it's something very easy, you have a counter that you want to have for your morning workout or something like this, nothing stops you. This is perfectly fine. But if you start adding many more things, like in here, this is, by the way, unreadable on purpose. I couldn't read it when I was writing it down, so it's all good. It's not suitable for large projects at all. If one person cannot really understand what is going on, then imagine having a group of 5 developers, of 10 and 50, like this is just not going to work. If multiple teams try to work even on different features, the chance that they are going to conflict each other, it's pretty much 100%. So what happens with monolith architecture is the fact that the build time of an application built in this way is going to be much, much longer than we would want it to be. And also, the defects are not going to be easy to find. So what we have in here is also a situation that is very, very prone to cyclic dependencies. And what's the answer? Microfrontends. Everybody knows that microfrontends is the way to go. You can see that microfrontends is an architectural design that is supporting splitting the whole application into smaller chunks that can work completely independently from each other, that can also have some small relations within each other, and that can be perfectly fine composed together. So the main benefits of microfrontends include autonomous teams. It's the chance for every single one of these teams to work completely autonomously, decide when they want to deliver the feature, decide when they want to do testing, etc. It's definitely shortened build time, right? Because when we can cache some of the builds already, there is no need to do them again. And what we can do is we can move to only building the parts that are changed. It's more flexible and manageable CI/CD infrastructure. So we can start with shifting everything to left. And the main benefits of that is obviously failing faster and knowing better when you have to take a step back and look at something. It's isolated defects. And you will see it later on, but it's actually much, much easier to not only contain the defect within the package that it is in, but also just to navigate to it. Well, independent testing, I already mentioned that, sorry. And then independent release. So, microfrontends are necessarily, and well, they are just the cure to all evil, right? But are they really? Ta-da! What about shared packages? So, you know that in a normal structure, when we are going to create our apps, what we're going to do as well, we're going to get the folder that is called packages. Now, what is going to happen in these packages? Our first instinct is to build everything in the same way as we used to before. So we're going to have packages, and in there, we're going to find components, flows, helpers, hooks, whatever we need to put in there. So what's the result? I remember getting into the shared components package and seeing this comment: do not try to sort these exports alphabetically, no matter what. So that was quite interesting to me. I obviously had to see why I can't do that. And then we've got the shared packages public enemy number 1, cyclic dependencies. So you will see multiple slides. I have to warn you, I am obsessed with cyclic dependencies, and I will tell you why in a few slides. But so far, just to introduce somebody who used to either live under the rock or who doesn't really follow things like this. What are cyclic dependencies? Well, cyclic dependencies are actually dependencies where two or more packages depend directly or indirectly on each other. So in a situation like this, easy peasy, right? We can just move things around. But what happens when we have 3 indirect packages? What happens when we have 5? Well, nothing good. So main risks that we have that are coming from having cyclics in the project are that they introduce this element of unpredictability. So we never know what we're going to get. Are they going to lead to resetting the values? Will they overwrite the values? Will they cause infinite building time with crashes? Or are we going to get white screen of death? So this is something that I ran into the moment when I started building or reorganizing the shared components package. The reason why I'm so passionate about this is this. This is what I started with when I was looking at our packages. So obviously, we were trying our best. Well, I was trying my best to find out what is going on. You need to imagine a situation when I was at my desk having a beautiful mind moment and having like all this A3 card of papers and just like trying to draw the lines. What is going where? Where did it come from? Well, finally, we finished on 5 well thought. So the first step to doing that was going for the low-hanging fruit. I showed you the packages where only 2 of them were depending on each other. What to do in a situation like this? Well, you just have to make a solid decision. Is it package A or package B? And then just move it. It's not that hard, but then we start cleaning out. So the second way to break the cyclic dependencies is actually to find the dependency that is offensive, and then move the file to a completely new package, breaking the cycle in that way. And yeah, that's pretty great. That's also something that we've done, but where did it take us? Over 80 packages to maintain. That's quite a lot, isn't it? Well, what are consequences of having 80 plus packages to maintain? Well, it is quite difficult to decide. Is it core hooks? Is it shared helpers? Is it core helpers? Is it native package? What do we do? So what we usually do is we are going the lazy way and we're just duplicating the code just in case we can put it somewhere where it's, it's logical to us that we can actually find it there, right? Then another thing that we're running into is problems with enforcing ownership of these packages. I mean, it's great to be on the core team where you have the code owners plugin and you see that there is nobody who wants to take care of any of the stuff that they put in the shared packages, right? So it's just like 2 or 3 poor maintainers who try and fix every single broken test, who try to see why something is not performant. And then, obviously, we've got too many relationships between the packages, and this is not only causing the issues with testing, this is not only causing issues with regression testing and normal testing, but also effectively, it truly prevents the independent releases. So you will see that having so many packages in a project where we have microfrontends is like, it's pointless. So we have a granular split, and obviously it is very problematic for automation, it is problematic for release, but why is it problematic? So let's imagine a situation like this. We've got a package called core helpers, we've got a package shared helpers that depends on it, we've got shared hooks that depends on it, and shared components. When we're going to make a change into core helpers, what's going to happen is we need to deploy core helpers, we need to deploy shared hooks, we need to deploy shared components and shared helpers. So, okay, it's 4 packages, it's fine, right? Well, but it's never 4 packages. Look at that. So we're adding another layer, core hooks, utils, native assets. Then we see another layer, so it's like core context, core utils with components. And it goes on and on and on until it reaches the mobile packages. To be perfectly honest, we run into a situation where if you upgrade any of the core packages, it means that you will have to upgrade pretty much every other one of them. So yeah, releasing 100 or releasing 85 packages at one time, it's not what microfrontends are about. And this is where what I can propose is future-driven design. So usually the definition of future-driven design says it's not meant to be product feature or not necessarily product feature, but in our case, that's what it was. The product feature-driven design was something that helped us with organizing the entire project. Now, in terms of feature-driven design, it's a methodology that says that at first, we develop our overall model of the product, of the feature, sorry. Then we build a list of features that are going to be developed within it. Then we're planning every single feature separately. Finally, we design by every feature, and then build by feature. It's a really great agile methodology, but as I mentioned before, it doesn't always mean that the overall model is going to be a product feature, right? So in our case, it is. And the reason for that is that with product feature design, it is very clear to describe all the project areas. So you've seen the home screen, right? We've got the mobile home. You've seen that we have support, so we've got mobile chat. You've seen that we have, as every bank, we have accounts, so we've got mobile accounts. Essentially, every single one of these areas is a separate feature, long feature within our application. Then it makes it very easy to actually enforce the code ownership. We've got a squad that is responsible for accounts. They are responsible for mobile accounts. We've got an insight squad. They will work on mobile insights. It's quite easy because even when we work together on certain features, we still know where the feature should belong and who should be responsible for building it. And this is where I go to implementing flows that are reusable. Because let's talk about, maybe let's not talk about this yet. Let's talk about the situation where we want to go and pay somebody. We're going to start a payment flow. And it's great, it's just a payment flow. But then let's think about mobile servicing. Mobile servicing is going to develop a feature of an account closure. So once the user starts the account closure process, they get to a state where they have some money in their account and they have to move it somewhere. What do? They start a payment flow. So an important thing that is going to come out very clear in here is that it is possible, thanks to product feature-driven design, to very easily enable embedding all of these shared flows. So now, what is the newsflash is that I would also like to propose to extend it to utilities. So, you remember all of these core hooks, core helpers, shared helpers, native packages. All of this is great, but you've seen all of the relationships built in place, right? Now you can see that we've got shared assets, because you will have shared assets. We still have things like hooks or models or even core components or just the components. But what is completely different in this is that we are going to group a lot of our utilities only based on the product features. So this is why we have shared accounts, shared onboarding, shared payments, shared rewards, and shared servicing. So that results in many less packages, and obviously it's going to bring lower the amount of packages that we need to maintain. It is much more readable because I think it's easy to say that a list of 20 packages and a list of 80, there is a big difference, right? And then in the end, obviously this is going to introduce less relationships between the packages. And in the same time, this is something that is going to improve the microfrontends architecture. So, the recipe for success is for flow relocation, is finding the origination of the feature. Now, you can see the screen with mobile rewards. Rewards is an area in our app where we have been collecting information about cashback for the user, where we have like all of the refer a friend money. So in the end of the day, what the user is able to do, they click the transfer button at the top, and they transfer the money to one of their accounts. So mobile rewards, transfer money to Alex's account, and this is the payment flow. In the same time, we talk about mobile payments. So this is one of the scenarios in which we are going from Alex's account to Annie Bench, who's going to get a free tenner, which is quite nice. And he's also going to start the payments flow. So obviously, the origination of this flow is not rewards. It's shared payments. It doesn't seem like a newsflash, right? But it doesn't work only for the flows. It wouldn't be that usable if it worked only for the flows as a concept. But in the same time, you can see that we have all of this stuff working on a lower level as well. So it is quite important that the utilities are as easy to move around as the flows. Let's imagine that we have a utility called Sanitize UK Mobile Number. For the first time, it's used in mobile onboarding, where we have our UK mobile number, we've given it in, we have removed all of the extra zeros, we've prevented any additional numbers, it works perfect. But then, later on, we have it in a screen that is in mobile servicing. So it's a screen where we've got updating the mobile number. Again, it's a UK mobile number, it's formatted without zeros, it doesn't have any extra digits or anything like this. So the origination of it, shared onboarding. So what did we actually get in return, having all of this put in place? Well, first of all, we got more time for development, because this enabled us to really make like very well aware decisions about where we put our items, but also very easily navigate to what is breaking on CI/CD, right? Now we have very clean messages about each package. We don't really have to, I mean, I know that for some of the errors, it could possibly be quite easy to just see where it is, but some of the problems, they are much easier. Yeah, how do I say it? Easier, much easily. They're just easier to find where you look at the screen, and you get to see that, oh, you know, this is something that I started in the payments flow, so this is essentially where it has to be. We've got ownership. I think that there have been a few talks about how ownership is actually enabling people to make more aware decisions and also take responsibility for their work. So we've very clearly described both shared packages and also the feature packages. The teams are very aware of what they put, where they put it, but also when it comes to solving defects or adding new features, they know that they are the people responsible for it, and they will be the people who are going to get the midnight call about incident when something goes wrong. I'm laughing because it's quite a similar situation to what happened in the talk that Nico mentioned before. A colleague of mine who's here with us got into an incident right before getting on a plane. So long live the accounts package. We also get a lot of independence. So the independence for the teams means the teams can write the features in their own time. They can decide that they will not release a feature because they don't think it's ready. I think if you've done the math, you've seen that I've been there for 4 years. The app was there for 2 years. So for 2 years, we have been making a lot of very independent decisions. And yeah, we did make the decision that we weren't ready, I think, a couple of times. But I think it's only a good thing that we released more or less prepared. Then one of the very important things that I don't think was necessarily mentioned is universal common language. So this is something that is quite important, not only for the developers, not only for the designers who work on the features, but also for the product owners. Now it's quite easy for the product owners to speak in different meetings about certain features, about speaking what they do in the defects, but also feature-driven design and it's the assumptions of it is to, well, just name things what they are, and that comes down not only to the package name, that comes down to all of the small helpers names. Like, I know that Sanita is UK mobile number, that does sound pretty granular again, right? But it is easy to mention to somebody like, oh, you know, on the +44 screen, we can no longer sanitize the UK mobile number because of this and that, right? And finally, it's obviously additional value for business. Why? Because when you follow the principles of feature-driven design, what is essentially coming to the fruition is a lot of packages that are very easily deployed, and they don't really, they don't really bring that many dependencies with themselves. So instead of having to force somebody from a different team in your company to download one of your packages and then 85 of its dependencies, what you can do is you can ship a package that has essentially what? 2 or 3 extra packages that come not from node modules, but from the internal Artifactory. So yeah, I think that's a wrap up. Thank you, guys.